Okay, what we are going to do is I didn't actually upload in the Google Classroom and AIS because it's going to be a revision. So we will look into the revision. Okay, the revision is going to be about hydrocarbons. Okay, what we have learned under hydrocarbons. And as you know, hydrocarbons, actually we have alkanes and alkenes. So we are going to actually learn about alkanes and alkenes today. So I'll show you in a while. Okay, now, so we will go through all this. Okay, I hope you can actually pay attention to whatever things that I'm actually putting over here. Now, so the revision on hydrocarbons, okay, we will look into alkanes and alkenes. Okay, so alkanes, we will start with alkanes. Now, alkanes will actually undergo this reaction called combustion. Okay, with the presence of oxygen, you are going to have complete combustion. And if you have limited amount of oxygen, you are going to get incomplete combustion. If it is going to be complete combustion, you are going to get carbon dioxide and water. But if you have limited amount of oxygen, you are going to get carbon monoxide and water. Sometimes you have carbon and water as well. So I want you to remember this: complete combustion and incomplete combustion. Okay. Now, another reaction that we need to focus on alkanes is going to be free radical substitution. It's a very important mechanism. So if I have a molecule, for example, here is a propane, okay, 1, 2, 3, so it's propane. So when I react with Cl2, okay, I'm going to actually get 1 chloropropane. Okay, I'm going to get 1 chloropropane, and we are going to write the mechanism. But before we write the mechanism, can we actually find out what is the condition required? Okay, Jody, what is the condition required for this reaction to happen?
UV, sunlight.
Yeah. Okay, UV light or sunlight. Okay, UV light or sunlight is one of the compulsory stuff that required condition that is for this reaction is sunlight is required to break the Cl2 into free radicals. So if you write the mechanism, so first of all, the Cl2 need to break, okay, the UV light or the sunlight, okay, will break the Cl2 into 2 free radicals. So if I want to actually write it in this form also, I just put 2 there and I just put like this. Or you can always write it down as Cl2, UV, and then Cl free radical and another Cl free radical. So what kind of fission that is happening over here, Frederick? What kind of fission? Homolytic or heterolytic?
Homolytic.
Okay, this one is homolytic fission. Okay, homolytic fission. Now, when you have this, okay, so that's going to be your first step. Second step is going to be propagation. Propagation is going to be when you have something that is neutral, then you are going to actually react with a free radical to give you more free radicals. So if I take this molecule, okay, this molecule, if I write it down in a structural formula, so it's going to be CH3, CH2, okay, CH2 and then CH3. And then when I react, okay, when it's going to be, plus. Okay, when I react with a free radical, okay, it's neutral molecule with free radical. So free radical, what's going to happen is, okay, the hydrogen, okay, will come out. So in this case, CH3, CH2, CH2, okay, the hydrogen came out, okay, to give you HCl. So you are going to get a free radical over here. You can see the dot over there. And what is next? Okay, you are going to have CH3, CH2, CH2, the free radical. It will react with a neutral molecule of Cl2 available, okay, Cl2 available, just like that. So it's going to be free radical with neutral. It's going to actually give you CH3, CH2, CH2, and then you have Cl, and you are going to get Cl free radical. Okay, so this reaction is enough already because they say it's for 1 chloropropane. So this is going to be the reaction for propagation. So what is important over here is you are going to get more free radicals. For termination, okay, termination step, it's going to be free radical with free radical. Okay, they will give you Cl2, or you can actually select any free radical, like for example, this free radical. So CH3, CH2, CH2, this free radical. When I join with Cl free radical, I'm going to get this. So that's also going to be termination reaction. As long you are going to get two free radicals joining together to give you a normal molecule, that's going to be termination step. So these are the three steps for free radical substitution. Now, so we will look into the reaction. That's all for the reaction for alkanes, you know. So one is combustion, the second one is free radical substitution. So now we will look at alkenes. Now, overall, when you look at alkanes and alkanes, okay, they have saturated bond or unsaturated bond, Janice? Alkanes. Janice?
Unsaturated.
Okay. Sorry, actually, alkanes is saturated. Okay, for alkenes, it's unsaturated. Okay, so alkenes is saturated. It means you cannot add anymore. Okay, but alkenes is unsaturated. You can add something. So therefore, the mechanism of the reaction is going to be addition. And to be exact, we don't simply just give addition. We just write it down as electrophilic addition. Okay, electrophilic addition. That's the mechanism of the reaction. But if you look at the reactions of alkenes, okay, actually I missed one of the reaction over here, okay, the zero reaction, I'll just put it over here. All hydrocarbons, okay, they will undergo combustion, similar like alkanes just now. So I missed this part, okay. But second, let's look at the other reactions of alkene. Now, alkene will undergo cracking, okay, with the catalyst of zeolite, okay. For example, why we actually use cracking? Because if you have a long hydrocarbon chain, it is not suitable. So if you want to use it for certain reactions, it's not suitable. It's better if you have a smaller chain. Like for example, if you have C10H22, you can break them or you can crack them using zeolite to give you C6H14 plus what? Okay, so in this case, Victoria, can you actually help to answer? C what?
C4H8.
Okay. Okay, so C4H8, can you actually tell me this one, C6H14, is it alkane or alkene? This is CnH2n plus 2, right? So this one is alkane or alkene, Victoria?
Alkane.
Yeah, alkane. And then C4H8 is going to be following CnH2n, so that's going to be alkene. So you can see that, okay, here, you are going to have alkane over here, okay. So alkane or alkene, whenever you have, okay, they will actually undergo cracking. So you are going to get either alkane and alkene. So I want you to remember this, okay. One of the steps is going to be cracking. Now, the important step over here is going to be for alkene. The important mechanism of reaction is going to be electrophilic addition. So we have a total of 4 reactions I've listed down over here. We will go through one by one. One is addition with hydrogen gas. Second is going to be addition with water, but not water in a liquid form. It's going to be in steam. It means it must be in gaseous form. And then addition with HX. And then the last one is going to be addition with X2. That is going to be HX is HCl, HBr, HI. So here will be the same as Cl2, Br2, and I2, something like that. Now, the other reactions, apart from combustion, cracking, electrophilic addition, we do have oxidation reaction. Okay, we will go through that again later. And polymerization. These are the reactions that is going to we are going to learn. Okay, actually we have learned. Okay, we have learned. So let's actually look at the electrophilic addition. So this one is for alkene. Yeah. So just now we have already covered for alkene. So the first reaction is going to be reaction with H2, and I have an equation over here. So in this equation, if you look over there, okay, I will actually write it down here. So here, if you look over here, the hydrogen, okay, they will stay as it is, okay. But the important thing over here is they are going to have this hydrogen. They will start to come over here, and then they will start to come over there. Okay, so the use of this, okay, the use of this, they are used in the formation of margarine. Okay, this one you can actually memorize. But what are the conditions? So this one maybe I'll ask some of you are afraid. what are the conditions to react with H2? Is there any catalyst involved? Is there any temperature? Fred?
Nickel
The rest get ready.
catalyst.
Yeah. The rest
Nickel
get ready. I will ask you
catalyst.
questions.
Then 150 degrees.
140. I think
Yeah,
140.
140.
Yeah,
Oh, yeah,
140. Yeah, nickel catalyst and 140 degrees Celsius. If nickel, they would have actually mentioned if it is just nickel, it's okay. Finely divided nickel is also okay, no problem. Okay, I want you to memorize this. Now, the second part is going to be reaction with steam. Okay, so what's going to happen? The steam is HOH. So what's going to happen is you are going to have the double bond broken. So similar over here. And you are going here, the OH will come over here. Now, what is the use of this? The use is to form alcohol. You can see alcohol. So the conditions, Jody, can you actually tell me the conditions for this? What are the catalysts? What are the temperature? What are the pressure?
I forget.
Concentrated. The rest, Elvin, concentrated. Okay, concentrated phosphoric acid, and then 300 degrees Celsius or 330 degrees Celsius, 330 degrees Celsius, and then 6 megapascal. Okay, I want you to memorize all this. Very important. Okay, very important. Now we will go for the third part, which is going to be reaction with HX. Okay, it is going to be in aqueous form. So the reaction is going to be, so you will have the H, and then H, you have H and H, similar like just now. But now one of the H will come here, Cl will come over here. So you are going to get, okay, from alkenes, you are going to get a halogenoalkane. Halogenoalkane. Now, this halogenoalkane, later also we will learn. There is a separate chapter on this. We have learned already. But I want you to look at the conditions. So what are the conditions for reaction with HX? Jason? Justin? Oh. Okay, let's not waste time. The rest get ready. Yeah? So the condition is going to be concentrated. Okay, concentrated. If we are using ACl, so concentrated ACl. Okay, and then it's going to be done at room temperature. Okay, at room temperature. Now, here, okay, before we go for the extra, I'll just go for the X2. Okay, if you have a reaction, let's say H with Br2, what's going to happen? You are going to have Br and Br used to as a test, okay, for C double bond C. It means the Br2, the color is going to be brown. Okay, so the brown color will be decolorized immediately. So if you want to test for carbon-carbon double bond, this is the best way to test by using bromine. Now, the condition is also quite simple. It's room temperature only. Okay, room temperature. Now, so let's actually look over here. Okay, here what I actually put over here is, okay, there is something extra over here. And I told you to remember, okay, the Markovnikov's rule. Now, according to Markovnikov rule, one of the students actually mentioned, okay, okay, this one I find it easier also to remember. Rich become richer, or I told you hydrogen will go to the carbon that has the more hydrogen. And according to Markovnikov, okay, the Markovnikov rule stated that the tertiary carbocation is much more stable compared to secondary carbocation compared to primary carbocation. The reason is because of the R group, the alkyl group, okay, will have the electron inductive effect. It's some kind of the electron is going to be given, okay, by the R group to the carbocation, making the carbocation to be more stable. So for example, if I have C and then R, and R, you have positive over there. The electrons will be given, electron will be given, making this carbocation more stable. Okay, so that is what they want to achieve. So you prefer to form carbocation, tertiary carbocation, but you can follow this method. So for example, if you have this example, okay, if I have HCl, so I need to find out where do I put the hydrogen. So obviously the double bond is going to be broken. So I'm going to have H, CH3, and then H and H over here. So where do I actually put the hydrogen? So the hydrogen will go to the carbon that has the most hydrogen directly attached to. Here you see 1 and 2. So here there is only one hydrogen directly attached to the carbon. So the hydrogen will come over here. Then the Cl will go over here. So the minor product and the major product, of course, this is going to be your major product. The major product is going to be this molecule. And then the minor product is the other way around. Okay, if you have the H coming over here, Cl going there. So that's going to be the other way around. So I want you to remember this, okay? Major product and minor product. So the major product follows the Markovnikov rule, okay? Because they tend to follow the tertiary carbocation is more stable compared to secondary and primary carbocation and so on. Okay, so I will actually go on to the mechanism of electrophilic addition. Okay, it is important to actually know what is the mechanism of the reaction. So the mechanism of the reaction is going to be like this. Okay, I have separated into two. Okay, one is going to be the reaction with HBr. Then another one is the reaction with Br2. Okay, so what's going to happen is, okay, first of all, if you have HBr, Br is more electronegative than H. So this is going to happen, delta negative and delta positive. That's the first thing that's going to happen. Second thing is, this is rich in electron. So they will go over here. Okay. So what's going to happen? So you still follow the Markovnikov rule. In this case, no difference. So I'll just put CCH. And then I put, let's say, for example, the H came over here. And you are going to get a carbocation, okay? And then plus, okay, Br, okay, because the electron went to Br, you are going to have something like a Br with lone pair of electron. So what's going to happen next is going to be, this electron will go towards the positive charge, and you are going to get this molecule. So if I write it in this way, you are going to have H and then Br over here. Okay. Now, if I actually try to write down the mechanism of the reaction for this one, okay, this one is going to be slightly different. Okay, why? Because Br and Br, they are the same electronegativity. So what we need to tell is, when they come near to this molecule, a lot of electrons over here will make the electrons over here to go towards one of the side further away, okay, from the electron, because electron and electron, they repel. So that makes this to be partially negative and partially positive. The rest is all the same. Just the first explanation, okay? It is because when they come closer to reach areas of electron, the electrons will get repelled. Nothing to do with electronegativity. The next is all the same, okay? You just need to join over there. And then the rest is going to be, you have H. Okay, I'll just write down quickly. You have H. This one is going to be positive. You have Br minus. And then this one will come over here. And then you are going to get.
Sir, why H, sir?
Where? Oh, sorry. That's Br, yeah? Thank you. So that's going to be Br, and then you have Br. Good. Okay, so this one is going to be what's going to happen. Now, we will go into the oxidation of alkenes. Okay, oxidation, we have two types. Okay, one is going to be using cold and dilute acidified potassium manganate. When they say cold, it's just room temperature. Another one is going to be hot, okay, concentrated, okay. So if you use concentrated, that's going to be breaking of the double bond. I think this one is way easier. Let's say I'll just give you one example. If you have this, okay, what's going to happen when you use cold condition? So you're just going to have only this. Okay, you are going to have OH, OH, a diol will be given. Okay, so when you are writing the equation, okay, I will suggest that you write down in this way. When they say, like, for example, CH, okay, when they oxidize, what's going to happen? You just need to have dilute, because dilute is going to be giving you the water. So when you write the equation, you need to include the water. So you have H, OH here, and then you have O, okay, over here. So what's going to happen is going to be these two will be giving you one OH, and this one will give you one OH. So you are going to get this molecule. Is that clear? Okay, that is when you are writing the equation. Now, we go to the difficult part over here. The difficult part over here, if you have, like, for example, like this, what you need to do, you need to actually break the double bond. And here, if you have H and H, it's going to be carbon dioxide and water. And then if you have like this, it's going to be, you just need to put O over there. So you will have C double bond O, CH3, and CH3. That's ketone. That's it. Done. So you are going to get total 1 product, 2 product, 3 product for this molecule number 1. How about molecule number 2? You break in between, and you are going to put a O over there. O, then C, CH3, and then H. This is going to be something like a aldehyde. Now, aldehyde will be further oxidized to give you carboxylic acid. Just put the O over there. Okay, carboxylic acid. And then this one will give you a ketone. Okay, so you have 2 products. Okay, let's actually look at the third one. You break here. Okay, here, hydrogen, hydrogen, you have carbon dioxide and water. And then here will be CH3, C2H5. So that's going to be just O. Okay, so you have total 3 products. Okay, now the last part, okay, we only have 3 more minutes. Okay, the last part is going to be addition polymerization. So basically, it's going to be monomer is going to change into polymer. Okay, so if you have the monomer ethene, it's going to change into polyethene. So how do I change it? Okay, it's better to actually, if you want to write the polyethene, okay, you just need to change, put the C, H over here, H over here, H over here, H over here. When you want to erase the part, or you want to show the part, just erase this part and then put like this. Okay, so then you put bracket and put N. So it means you are going to get something like this. This is polyethene. Okay, now the problem with polyethene, okay, you can see over here there is unsaturated bond, but here they are all saturated. Now, if you have all saturated bond, okay, the problem with addition polymers are they all the saturated, they are lack of reactivity. So it means they are resistant to chemical change, they are resistant to bacteria and so on. So it's difficult to actually dispose them. Now, the only option over here is to actually burn them. But when you burn, okay, it might give you toxic gases. So these are the things that you need to remember for this chapter. Okay, so I'll just show you slowly. Okay, there are alkanes and alkenes, all the reactions you can just slowly see. Okay, these are the things that we have learned. Electrophilic addition reaction, all the conditions and mechanism and so on, Markovnikov rule. Okay, and then how to write the mechanism of the electrophilic addition reaction, oxidation, very important, and then a little bit on addition polymerization. Okay, that's all for today's lesson. Okay, do you have any question, guys?